excited to be here. I hope you are as well. We're going to start the conference off today with a session on just how to use your conventional and or unconventional experiences in a tech career. Now, my path is a little bit unusual in the fact that I actually have a bachelor's degree in music. That's me at my senior recital there all the way on the left. And then I graduated with that and I moved into computer management and information systems for a master's, which was a blend of a master's of business and the master's in computer science. So kind of a blend of the business and the computer science degrees. And then I went from there into developer advocacy. And that's where I've been for the last 7 years now at Neo4j and still loving it. Now, first off, I must give just a little bit of a disclaimer that this session will be full of science fiction references, which I think I'm in good company here because this conference tends to bring their A game on Star Trek and Star Wars mashups. But don't worry, if you're not a science fiction nerd and or Star Trek, Star Wars, I will explain the references as I go along. So you won't be left out or left behind. Okay, first off, what do we think of as conventional? When we think of someone who has a conventional career in technology, where have they come from? What have they done? And oftentimes what we think of is someone who has played with technology as a kid. They've maybe built computers or they've done some programming, introductory stuff, maybe messed with wires and wiring computers and lights and all sorts of things up. Then maybe they've graduated with a degree in computer science or a tech-related field, and then maybe they have a developer job as a day job, right? So they program during the day. But even if you fall into these categories, remember that conventional is the average of all sorts of things, right? And we all don't fit averages to a T. What about all the other kind of typical developer stereotypes? Things like poorly lit room, poor social skills, t-shirts and hoodies, coffee, lots of coffee or caffeine, and all sorts of other things. Geeky. Now, I'll admit that I fall into several of those categories, and I'm okay with that, but I definitely don't fall into all of them. And really nobody does, in fact. So convention, I want to add, is not bad. It does exist for a reason, right? That specialization is very needed and very helpful. Those in-depth technical skills, the general processes, the background and the history of where computers and technology came from, that's all super valuable and important. But my message here is that it's not the only way that you can get into a degree in tech, and some other skills and some other experiences are valuable as well. The example I'm going to use for this one is the Kobayashi Maru. Now, if you're not familiar with Star Trek or the Kobayashi Maru, it is a simulated space test that every soon-to-be graduate of Starfleet Academy, which is the kind of university, if you will, to graduate and become a space explorer and to serve on starships in Star Trek, is you have to take the Kobayashi Maru. And it's a no-win scenario test. And they just want to see, how do people react under pressure, under anxiety? How do they make decisions? Can they function in this high-stress environment? Are they willing to lose people in this exam in order to come out the other side? And of course, everyone is supposed to fail. The test was designed that way. But James Kirk was the only one to actually defeat it. And the way he defeated it is that he reprogrammed the simulation so that it was possible to rescue the ship, which actually, as I've started reading some of the things that are going on in AI right now, where you're starting to see people try to hack the AI or outsmart the AIs, that's kind of exactly what this is doing, right? But that didn't make Kirk a better student or a smarter student. It just made his approach different, that he defeated the test and no one else could. In some scenarios, other students would definitely be the better captains and do better in certain situations. And then in certain scenarios, you needed someone like James Kirk to kind of think outside the box and do something no one had done before. So it just makes their approaches different. There's a couple of assumptions I think that are made when you have the idea that there's a single method or a single path into any one thing, but tech specifically. And again, convention isn't bad, but there's assumptions a lot of times that go along with this. And the first one is that the tech industry is stable. We'll talk about this one. The second one is that tech skills are more helpful, more valuable, more important than non-technical skills. And then the third one is that tech is not an element of other fields. We'll talk about each one of these in a little bit of depth. But If you don't know, the reference here is that the Millennium Falcon, which is the ship in Star Wars, most people called a rust bucket, it wasn't space-worthy, and so on, it actually beat the Kessel Run record in 12 parsecs. So we can see how kind of the typical conventional sometimes doesn't defeat the odds. All right, and my shirt kind of matches that today. So we'll talk about each one of these. Now, most of us, if you've been in tech, we'll talk about the first one. So the idea that tech is stable. Most of us have probably heard this phrase, if you've been around tech for a little bit, of move fast and break things. And this has kind of been modified a little bit. Of course, you don't want to throw junk into production. You want to have something halfway decent that you release. But often we hear this phrase, move fast and break things. But why is this the mantra? Why do we use this in technology? What's the purpose of this? What's the thing of being linked with the tech industry for this? So to understand this a little bit better, I think we ought to just look at the last 20 years or so of technology innovations and phases, if you will, and kind of see where this is coming from, maybe. Now, the first one I'm going to start with, we're going back 20 years. We're in an odd year in every 5 year. So I thought I would go back all the way to 2005. Now, in 2005, YouTube, Reddit, and Google Maps were all launched that year. Personally, I cannot imagine a world without YouTube or Google Maps, but it did exist before 2005, apparently. Also, the term selfie was coined. That's going back quite a ways, right? And really what we saw in 2005 was a huge explosion of blogging. Now, this wasn't just tech blogging. It was anybody who had a passion or an interest or something they'd experienced would share what they had learned or what they knew or what they liked about whatever subject it was on the internet via a blog. So this changed a little bit how we consumed information. It was much more personal, it was much more accessible, and people started blogging and kind of talking about all different types of topics. So it changed a little bit in how we interacted with information as well as with each other just a little bit. Now in 2010, this kind of changed again. We had e-readers and tablets really come onto the scene. The Apple iPad was launched that year, but you saw a lot of explosion in digital content, so ebooks and other sorts of media that you can now access on smaller devices, tablet and e-reader formats. Instagram, Quora, and GoFundMe were also launched that year. So again, changing the paradigms of how we interacted socially on the internet. Instagram being kind of that picture rather than text or statuses, if you will. And then, of course, GoFundMe, looking at how do you support things you're passionate about or things that you want to support via digital payments or sending money to places, right? So we were starting to do those things over the internet. And then in 2015, this was really where the big data and cloud environment started coming onto the scene. You had things like Netlify, Discord, and Kubernetes all coming on. Again, Discord changing the way we interacted in a digital environment via more chat and message approach, a little bit more real time. But then, of course, Netlify and Kubernetes supporting that big data cloud type of environment. And of course, those were the big terms at the time. Also, though, you had some changes to devices. So the Apple Watch launched that year, so wearables, and Amazon Echo launched that year, so getting into smart home ideas. And then also, Android and Samsung Pay launched that year. So again, kind of changing the paradigm of how we transfer money, now going more towards devices and transferring money digitally. 2020, we all saw a huge change, right, in environments, but this came onto the scene with remote access and Zoom and digital working environments and meetings and all sorts of things. You also had a little bit of shift, again, in our social paradigms, right? Because we couldn't get out and visit in person, and so we did a lot of things over the internet. Things like Slack were really huge, of course, Zoom, the way we work, and then Twitter Spaces launched that year too. So again, just changing how we interacted socially as well as in our work environments too. And then finally, in 2025, now we still are very early in 2025, so these are themes that I've seen over the last couple of years really surface. But we'll see where 2025 takes us for the rest of the year. The first one is AI. That is still a big deal, but we're going to start seeing how this integrates into daily lives and all sorts of other systems and industries beyond just technology. And then data breaches and data leaks have existed for a long time now. There were several of them that occurred back in 2015, 2020, and all the years in between. But I feel like you see them a lot more. They're almost a weekly, monthly occurrence, if you will. They're just part of our daily lives. And I think we're going to start seeing some things to address those as well as working with them in our average daily digital lives nowadays. Okay, so we've seen how technology has moved from the last 20 years. It's shifted quite a bit. But what do we get as a result of this very fast pace? What's going to be the outcome of the tech industry from moving so quickly? Now, again, I'm going to kind of paint with broad brushstrokes here. These are not always going to be true, but I think it is a general tendency. These are things that kind of result from moving fast and breaking things. The first is that I think we prioritize solving problems and solving human problems. And there's a lot of other things that kind of fall by the wayside, again, for good or for bad, but we want to solve problems and we want to solve them quickly. And we want to contribute to society. We want to give back. That's why you see a huge focus on open source and contributing projects out on GitHub that are open and people can see and reproduce. We want to solve human problems. We want to help the world. We want to improve it through technology. Now, we also tend to see a focus on skills rather than qualifications. We'll talk a little bit more about this one here shortly. But because we want to move fast and break things, if you will, we want to contribute, we want to get stuff done quickly, I think we tend to prioritize you having the skills to bring to bear on a problem rather than you've done this problem, you've solved it before. Because again, we're moving fast. We don't solve things multiple times typically. The next thing is that we tend to prioritize experimenting and iterating. Now again, this isn't to say that you throw something up in production just to get it out. You want something that's high quality, but we're always willing to learn and experiment, and sometimes you don't know what you don't know until something's live, right? So we typically think that is a good thing. We put something high quality out there, knowing that we're going to change and iterate and move as things change over time. The last thing I think, again, painting with broad brushstrokes here, is that because we prioritize solving problems quickly and we prioritize skills over qualifications, we tend to provide a little bit more flexibility in other areas. Things like flex hours or time off or different regions and living styles and all sorts of things that I think generally technology industry as a whole tends to be a little bit more flexible than some of your other industries out there. So these are the things I think that you get when we prioritize faster pace over a lot of other things. Again, for good and for bad on both things. Now, to support this very fast pace, what are some of the things that we need? I think this is why we're seeing a continuous rise in unconventional paths. So we have a lot of people still today that are hobbyists or part-time developers or part-time open source contributors and so on. They do have other day jobs and then they contribute on the side or as they have time. And then there's this kind of self-taught category, and most of us probably think of people like Bill Gates, Steve Jobs, and Mark Zuckerberg, who maybe didn't complete their college degrees, even though they had some formal education, if you will, but they weren't necessarily qualified to run huge tech companies as they did. So, but then you're also seeing career shifts, and I'm one of these. But I actually work with a ton of colleagues who are in the same boat. They've shifted from another degree program or other industries or so on. Something has sparked their interest, they've moved into technology, and that's where they've stayed. And we'll talk a little bit more about that over time. I'll explain a little bit more about my background. And then you've seen a rise in boot camps. Now, I have a couple of thoughts on this one of why this is. We just talked about how technology has changed over the last 20 years. Every 5 years or so seems to be totally different, right? If you think about a traditional degree program, 2, 4, 6+ years of education, think about how fast the tech industry changes. We just looked at every 5 years, how different it is. Most of the college classes that you would take in your freshman or early years, they would be totally different, or maybe not even relevant by the time you would graduate. So it's really hard for other industries to keep up and to be formally trained. And if you think about how many job roles didn't exist 2, 5, 10 years ago, there's a couple I can think of off the top of my head. The first one is data scientist. When I graduated less than 10 years ago now, my degree program was just the following year, the following fall, was going to put in a data analytics specialization. So it wasn't even an offering at my university to do a data analytics or data scientist degree or even minor at that point. It was a specialization. You could take a few college credit hours and add the specialization onto your existing computer science or CMIS master's degree. So it was relatively new, less than 10 years ago. There were no formal training programs. And you think about how big the data scientist community is, it would be hard to formally train on somebody who has less than 10 years of experience. There's no way to be qualified that. There's no programs. The other one I think of is AI engineer. Do you know of any degree programs that will train an AI engineer and you graduate with some kind of degree in AI engineering? Probably not. There may be some formal training, some classes, or maybe smaller degree programs, boot camps, things like that would offer that. But again, most of your standard educational long-form education aren't going to have programs for that yet. And there's a need for that. So how do we go about filling those holes? So we can already see that technology is not stable. It moves very, very quickly, faster than most other industries. And that means that it's going to be hard for education or any other sector in any other industry to keep up. It's hard to formally train those skills because things just move too fast. All right, so now let's look at the next one. Now let's look at how tech skills might be more important, more helpful, et cetera, however you want to term that, than non-technical skills. Let's debunk this a little bit. First off, what does qualified even mean? I kind of define qualified as I have the experience, I've done this before, right? It might be a bullet point on my resume. I've solved this problem, I've built this thing, I've done this project, and so on. But if you think about what a lot of our innovators are doing, these are things that haven't been done before. And I'm going to take a couple of media examples first, and then we'll actually go to some real life examples. But if you look at Star Wars, actually the only one of those three that's really qualified to lead a rebellion was Leia. She had the diplomatic skills, she had the background, she had the strategy, she had the leadership skills. Neither one of the other two were anywhere qualified to be leading a rebellion. And look at them standing up there up front, right? So, and same thing, look at Star Trek. Their whole motto was to boldly go where no one had gone before. How can you be qualified to do that? It's never been done. You're doing things that are new. You're experiencing new planets, new civilizations, new people, new cultures. How do you be qualified to do those sorts of things? So it's really hard to be qualified to innovate. And if you look at examples from the past, most of these people popping up on the screen may or may not have technical backgrounds. They're coming from other fields. They're innovating and doing really cool things with tech, but they're not necessarily qualified to contribute to technology. No one had done before what they were doing. They were innovating. They were on the edge. Many inventors were mathematicians, astronomers, philanthropists, scientists, all sorts of other backgrounds. They weren't qualified as tech people. There weren't so many delineations between studies either. Let's take just a couple of specific examples we'll zone in on. First of all, if you have not read or watched the movie Hidden Figures, it is a fabulous piece of content, a really interesting story about Katherine Johnson and her work and her life. She was a math major, so she had, I guess, a little bit of mathematical, technical skills. We can see a lot of overlap there, maybe. But she wanted to be a research mathematician. She ended up working for NASA, or what would become NASA, and she was referred to as the human computer because she would calculate all of the physics and mathematical calculations it took to send payloads, ships, et cetera, and people into space and return them back to Earth safely. So run all of those numbers initially by hand. And then when computers came onto the scene, you would feed in numbers to the computer, and she would cross-check those numbers. She would run them all by hand, look at her numbers against the computer's numbers, and make sure they were accurate, right? Because you wouldn't want to necessarily trust something totally new to send somebody out into space and hope they come back. So she would run all those by hand again and cross-check that the computer matched what she expected and what was needed. And then, of course, over time, humans became kind of the input people, right? They would input all the variables and the numbers and run the scenarios and get those results back. Over time, of course, we've shifted to more of a computer-oriented society. And that saved a lot of workload in a lot of ways. Once she retired, she actually supported STEM efforts as well, so speaking and other types of support for science, technology, engineering, and math careers. So she did a huge amount of contributing to science as well as technology, and then later towards STEM education. Let's take one more example here. This might be a little bit lesser known, Elizabeth Friedman. And I just finished this book actually last week. That's referenced up on the right-hand corner. It's another fabulous read. If you're not familiar with kind of the cybersecurity or some of the code-breaking aspects of technology. So this is a really interesting story. Elizabeth Friedman, her husband was also a code breaker as well, but Elizabeth's story is just maybe a little bit less well known. She was an English lit major, and she also really enjoyed languages, linguistics. And it's interesting because she was later given a Doctorate of Law degree, and that's because she testified so many times in court with her code-breaking skills. So she'd get up into court, she'd testify against whoever it was that this was the method she used to decrypt the messages, and they initially, because she spent so much time in court, presented her with a Doctorate of Law degree as well. But she was, her first project out of the gate after university was called the Bacon Cipher. If you're not familiar with this, it's kind of a conspiracy theory where you have Francis Bacon, who supposedly wrote Shakespeare's works but used Shakespeare as a pen name, but he left clues to his identity in Shakespeare's works itself through code. And this was a project she started out on. Of course, she later didn't feel it was a valid or a real code, and so she did some work in writing on that as well. But this was the first project she got out of the gate. It's what exposed her to codes and encryption methods and patterns, right? But then she moved on after that, and during World War II, she worked to break encrypted messages for the United States and allies as well. And then between the wars, she worked back in the Second World War as well, but between the wars, she actually decrypted messages for alcohol smuggling during Prohibition. So they were sending messages back and forth on alcohol trade, and she would break those messages and help decrypt them. And then again in World War II. Now, this is the piece that I find really fascinating, because she went back and decrypted messages for the Allies as well. But all of her work, she later did a bunch of documentation on both her and her husband's careers, and most of the foundations are used in encryption and cybersecurity protocols today. So all of this research and study, she did all of her initial work by hand. She didn't really use computers or technical things at that point, but all of the encryption methods and the alphabets and the patterns and stuff she published, and we're still using those things in technology today. Things like hashes and so on. She was a code breaker. She did all of her stuff by hand. But then, of course, as we started getting into the world wars, and between those, you started having encrypted messages sent via radio. So she would intercept those messages, she would decrypt them, and send them on. And then what I find super fascinating is during World War II, you had encryption machines like Enigma and others that the way their gears and the letters would coincide to produce these multiple alphabet encrypted messages and so on, it's super complex. They didn't have those machines, so the enemy did at that point. And she would not only just look at the patterns and try to analyze them, she would figure out how the machines worked without ever seeing one. She didn't know the wiring, she didn't know the way the gears moved and the letters shifted, multiple alphabet ciphers going on. And she would figure out how the machine worked and decrypt the message, just based on the text and the patterns of the jumble of letters that she had intercepted. Super fascinating that you could backward engineer technical machines and very confusing code encryption topics without ever seeing the machine that's actually doing the encryption. So really fascinating story. Okay, let's look at my story a little bit and how my skills transferred to other careers. Now, I've always been a nerd. That's undeniable. I just shifted from a music nerd to a tech nerd. And again, I'm okay with that. But one of the things that set me apart even as a musician was that I really loved music theory. And music theory, if you don't know, is the underlying structure and patterns that exist in music. So you'll have themes and melodies and harmonies and chord progressions and all sorts of things that go into producing something that sounds pretty or sounds interesting, right? And most of my fellow colleagues and friends didn't really like music theory. It was a lot of structure, a lot of math, whatever. We just want to play. We want to sit in a practice room, we want to play. But I actually better understood the music when I knew what the structure was underneath it. I could understand it better, which also gave me increased confidence when I would perform. It gave me better memorization skills and less fear of losing memory when I would stand up and play something without looking at music. And it would give me a little bit more artistic license because I knew where the piece was going. I knew where it was supposed to end up. So it gave me a lot more freedom and a lot more comfort knowing the structure and the music underneath. I'll give a slight little anecdote here, is that I gave a senior recital also when I graduated high school before I went away to college. And I had kind of a thank you to all those who had been involved in my career at that point. And so I did a little bit of half speaking, half concert, if you will, musical playing. And I was far more nervous about the speaking portion than I was the playing portion, which is a little bit ironic considering what I'm doing and where I am right now. But I was definitely more nervous speaking than I was playing because I felt like I could prepare and understood the music a little bit better than just kind of off-the-cuff thoughts and words stringing together. I also, though, ran my own music lessons and special events business at the time. So I started kind of getting into this. I would play for dinners or weddings or what have you. And then I taught music lessons to students of varying levels and ages and such. And I started to see very early on that, hey, some of these technical business skills are actually pretty valuable even in music. So I started to see that overlap, and I moved into a minor, took on a minor, a business minor, and that's where I really got exposed to formal programming, if you will. I'd had some previous exposure to programming, but that's where I really started to get into like the Java classes and things like that. And as I took some of these, I really just saw more and more overlap between music and technology. And the interest and the fun and the challenges that it gave were actually pretty similar to music. So that's when I moved. I went ahead and finished my bachelor's degree. At that point, I was relatively close, and then moved on into a computer management and information systems master's degree. And pretty soon after that, got my first tech job as a developer. I was programmer analyst for a national financial investments firm, and learned a lot there. Got a ton of great mentors and people and technology experience and exposure there. But it's interesting because a lot of the things that I was doing, I was using structured query reporting, which is SQRs, which is kind of a data interface. So I would run queries against a database, I would format that data and output it into reports, which is kind of interesting because I would run queries and work with data, which is kind of what I'm doing right now at Neo4j, right? I'm working for a graph database company. I do a lot of data and a lot of back-end stuff right now, and I love that. But some of these skills early on prepared me actually for what I'm doing now. Now, there's a few skills that you might say, okay, that's great and all, but how do I actually look at the conventional skills that you might get in a regular tech degree or other type of conventional methods? How do they actually overlap with the experiences and the education that I have? So let's just do a little bit of a mapping exercise. And we're going to use my experiences as the mapping factor, but of course you can contribute these to your own as well. So in a conventional type of path, you might get things like creative construction, how to assemble things, how to wire things to connect and parts to move and all sorts of interesting things, right? Play with software and components and things. You'll get some architecture background, how things fit together, how data flows or moves through different processes. You'll get some debugging knowledge. How do I solve problems and fix things that go wrong? And then best practices. What typically works, what typically doesn't, what have people experienced and explored before and come up with good or bad solutions. Now in music, I get kind of these stack of skills. I got the music theory, the structure of the music, and then I would implement that in practice, right? And then I would look at orchestra. So I would have orchestra as a big group of lots of different types of instruments, lots of different musical parts that all have to fit together into this very full, beautiful whole, right? I loved orchestra. But I would have to go and practice my own part very hard on my own, and then I would come into practice with the full group, and we would all put our parts together. And then, of course, working out the kinks and stuff that go along with that. Then I taught music lessons, so I would have to portray different concepts in a variety of different ways for different learning styles, different age groups, different skill levels, and so on. And then I ran my own music business or special events business, so I would handle the logistics and the performing and the practicing and making sure the music that people wanted was present and all that. Now, where's the overlap in that? First off, you get technical mastery. Musical mastery is about breaking down tough passages in a piece of music, getting those perfected or refined, and then assembling them back into the full piece, right? And then looking at breaking things down and iterating. So, okay, this didn't work. Let's break this little piece down. Let's fix this. Let's change it again. Let's see if this is easier, and now let's put it back into the whole. Which kind of sounds a little bit familiar, right? Cause and effect. When you construct a piece of software, you work on refining the functions or the methods or the classes, and then you put that full into the application or the service orchestration or what have you. You assemble all those pieces into this beautiful whole, right? And then looking at how things work. So when I turn my bow this way, I get this sound. When I structure and move my hands this way, this passage is easier or harder to play. Also sound familiar? When I structure my code this way, it works much better. It's more efficient. When I construct my prompt this way into ChatGPT, I get better results or worse results. It's cause and effect. We get those skills in a lot of different ways. And then, of course, the collaboration and communication, working with other people, communicating your thoughts and what you need and what you want and what the thing is doing and so on, all are really good, helpful things. But what do we get if we were to all go through the same trajectories, the same experiences, the same jobs, the same whatever? You get a very one-size-fits-all. That makes us mostly clones, right? And our training, our experiences, and so on, that's going to limit our ideas and reduce our exposure to new and inventive things. I have a couple of examples of this. First off, when I graduated high school, I went away to college for just a few months. Didn't work out, came back. But while I was there, I had a violin professor that was a phenomenal player, but all of her students had to play a certain way. And when I got there, I went back all the way to basics. Basically, I was relearning the violin all over again and just playing open strings, not really doing anything complicated. And we did that for weeks, semesters on end. Again, I only stayed about a semester of that. But when I would go to master classes or listen to her students play, they would all play the exact same way. They all had the exact same equipment, so they had the same shoulder rest, the same rosin on their bow, the same style of playing, the same form. Everything was the same. And I just really felt that it wasn't taking into account different body types, different styles, different backgrounds, different experience levels, and so on. My neck would be shorter or longer than somebody else's. I can't use the exact same violin somebody else is using. My arm is different shaped and extends, my shoulders, all different. So you have to accommodate this natural way of playing to fit somewhat you as well. There's another example. My sister went to a museum exhibit all about Van Gogh a few weeks ago and said that his early style was very dark and somber, which matched the Dutch art at the time, so what his influence and surroundings were, right? But when he moved to Paris, that's when he experienced the brighter colors and more modern approach, and that's where he flourished into his very own unique, iconic style that we know as Van Gogh today. So he had to be exposed to something new and different, something outside his wheelhouse, in order to develop into his own unique individual style. Sometimes we need those external outside opinions. Let's go back to entertainment a little bit. What makes something interesting or valuable? In Star Trek, you have the same mission and different strengths for each one of the crew members. They all had a focus. They all had a strength. Some problems you needed some person to solve, and some problems you need somebody else to help with. Think of an orchestra. Each person's going to play a part. Entertainment today, the most interesting ones, movies, books, music, any of it, what makes it great? You may have a single star element, if you will, or one that's kind of the main focus, but there's a lot of supporting intricate melodies, harmonies, and structure, and so on that goes along with that. Think about tech systems today. What are your most valuable tech systems? Those are only valuable when they're exposed to real live data sets and real live people and user interactions, right? Most of us probably go, oh no, what's the user gonna do to my system this time? Right, when we hand something over, they're like, oh great, here they go. But user testing is so valuable because we see what we have our blinders on. We don't see what we don't see. You have to hand it to somebody else and let them contribute those ideas and those unique viewpoints that we may not necessarily see. And that's gonna help us support a lot of different angles, a lot of different needs, and make things more accessible and more helpful to a broader audience base. Now, I'm a parent, I have young kids. I have a 4-year-old and 2-year-old. And my 4-year-old has gotten to the point where he asks why all the time to everything. And yes, sometimes it's frustrating, sometimes it's entertaining, but you start to think, well, why is that way? Well, that's a really good question, kiddo. Why does it work that way? Or why does society function this way? I don't know. We need that fresh new perspective. More of us should have that 4-year-old mindset of why do we actually do this way? Expressing those new perspectives on the norm, we get so focused into our habits and our responsibilities in our daily lives that sometimes we forget to take those blinders off and look at something different and new. So stick a pin in that. We'll come back to that point here in just a second. All right, so tech is not stable, and we can see how a variety of different technical skills can lead to more resilient, well-rounded systems, right? Better, more innovative, more functional, more accessible, all these sorts of things, better systems. Let's look at the last one, that tech is not an element of other fields. So first of all, if you look at STEM, science, technology, engineering, and math, technology is the newest field in that group. It's sourced from others. All of these people, or most of them, may not have had technology fundamental backgrounds, but they did innovative things with technology. So technology was used, again, to solve human problems in other industries, in other places. We used technology to support those other industries. And we were able to use technology to benefit those. But now look at the reverse. Technology also feeds other fields. So technology came from other fields, but it also feeds other fields. So I'm using the example of Anakin Skywalker. If you're familiar with the Star Wars series, he was supposed to be the chosen one, the one that would bring balance to the Force. He started out as good. They trained him to be good. He turned evil. And then in the end, he defeated evil and redeemed himself and became good again. So it's kind of the symbiotic relationship. He did bring balance, but through a roundabout way, I guess. But if you think about technology and other fields, they also have this very interwoven, very connected relationship. You think about agriculture, looking at crop health, tracking weather systems, and nutrition for the food being put on people's tables. We use technology to feed those things. What about sustainability? Looking at where things come from. Can we get better with logistics and cleaner products and so on? Looking at dangerous jobs. Can we save people and prevent injuries or cause less harm to the human race, right? Overall, can we make these more safe? And then looking at traffic flow, so sustainability and efficiencies and flow and safety and all those sorts of things for people just moving about the world. Healthcare, looking at robotic limbs, understanding the brain, and then studying and hopefully curing chronic illnesses and cancer. And finally, looking at just daily living. Think about shopping experiences and delivery, getting people access to things that they wouldn't normally be able to participate or get access to. And then, of course, a wide range of global products that we can now get to because of technology and digital. Let's look at my example. So I talked about that I taught music lessons and I ran kind of a music business, if you will. I saw those business skills already becoming valuable in my music industry. But I also had a couple of other examples. So while I was in school, I worked for the music library, and I had a lot of different parts, all different types of pieces of music that the orchestra or the choir or whatever would rent out and play and have a concert for that semester, and then they give those parts back to the music library and so on. And it was really hard to keep track of what was missing, what needed to be filled in, if there was a piece we even had, and so on. So I built a music library database. I digitized all that information. My colleague and I went through the entire library from top to bottom, every part against every score, and so on to figure out what was missing and what we needed. And I digitalized all of that. I don't know what the state of the system is now, but that's okay. And then I also took a cyber arts class, which was a combination of fine arts and technology. So looked at the relationships between art and tech in graphics, music, video, and film. If you think about a lot of what I'm doing now in developer advocacy, I'm creating diagrams and slides and putting together videos and constructing all this sorts of this digital media that's very artistic and yet very technical as well. I was exposed to a lot of tools that are used in fine arts. And then music also feeds my current career. You think about exactly what I'm doing right now. I grew up performing and playing concerts after working really hard preparing my material. That's exactly what I'm doing on this stage today. It's about preparation and storytelling. A presentation should have a good story. There's an artistic, interesting element to it. And then composing those master details, those little bits of information I want to feed throughout the presentation, it's about composing those into an interesting whole story that comes into a whole presentation. Now, I came across this screenshot actually from a presentation that was given at Java 1 in 2017. And if I find out whoever gave the presentation, I'll definitely credit them. But good code should read like a story, not a puzzle. So again, it's that storyline, that artistic element, that code should be that way as well. There should be that technical component. There also should be the storyline that goes with that. So tech also feeds other industries. That's how we're going to know where the gaps are and how we can fill those other gaps. I like to think of technology as a central hub for everything else. You have somebody coming in that can use those tech skills and then slingshot off to somewhere else, because those tech skills all kind of overlap to some degree. So someone who's an artist will understand the combination between beauty and function. Someone who's an architect understands systems and contingencies. Someone who's an educator knows how to do learning and application of that learning for various styles. Someone who's a health professional understands the blend between necessity and humanity, right? People with those first-hand skills in other industries will be key to finding those gaps and filling the new gaps as they arise. Okay, so now we can see that tech and other industries are a symbiotic relationship. They feed one another. We need technology in other fields. All right, so how can you go about leveraging your skills? First of all, I want to ask you, what's your why? Something has sparked your interest in tech and has brought you here to a tech career. What is your why you're here? Maybe you're intrigued by the potential as it grows and changes. Maybe you're frustrated with a gap you experience elsewhere. Maybe it's just because it sounds fun or challenging or creative. Whatever it is, what brought you here, and is there a problem you could solve for somebody else down the line, the next person? We're going to look at how to leverage your skills in 3 steps pretty quickly here. First is to identify your strengths, to map those strengths to a field in tech, and then finally a little bit of positioning or messaging, if you will, for the certain things that don't feel like they map very much. Okay, so first up is to identify your strengths. What are the things that you enjoy? Remember that technologies come and go. I'm not working on the same technologies I did just a few years ago or even a few months ago, right? Technologies come and go. What are the skills that you're learning from the technologies or the things you've explored now? What are the things you enjoy that frustrate you, that you wish people knew? Maybe it's poor documentation, ease of use, improvements, efficiencies, and so on. For example, my experience, I really like detail-oriented things, learning and organizing stuff. Now again, if you have technical skills to bring to bear or can pick up some technical skills through self-learning, those are just as valuable, but I often find it's a little bit harder to map those obscure or non-technical skills to things you're working on. All right, so once you've done that, remember that skills are more important than qualifications. Try to figure out what will transfer from your previous experience to now, what sparked your interest, or maybe just look at your pet peeves. Then how do we map those to technology? First of all, remember that learning and building that learning muscle is more important than a certain stack. So again, whatever stack you might choose, that's fine, but what is it you're going to pull out of it? What are the skills you're going to get from whatever thing it is? And then apply. Remember that upskilling and reskilling is common. So whatever you're working on now, it may not be relevant or valid in a few years. What are kind of those base elements that you're going to get from whatever technology or thing you're working on? In my example, I did both performing and organizing when I ran my special events business. That's kind of like project manager and developer, right? So I got a lot of different interesting skills. And as a developer advocate, I'm still using those skills today. I'm building technical content and I'm presenting it. Plus, I handle all of the logistics of booking travel and expense reports and all the other sorts of things. And then I also was a music teacher, so presenting those very intangible concepts of how do you play this or represent this piece of music this way, and explaining that to a variety of different people, various skill levels and ages, and so on. We could take an existing example right now of AI. What are some ways and skills that you might have that might be a little bit unconventional? We're going to need a lot of different skills to support AI going forward, right? We're going to need things like power sourcing and power consumption, data privacy and ethics, information quality, human behavior and psychology as we start building logical and reasoning models, right? And then, of course, all the technical development and integration that has to go along with supporting those systems. So we're going to need a lot of different diverse skills in order to support AI going forward. Now, a little bit on the messaging. This one is a little bit easier said than done because society tends to view failure in a bad light. But success stories will never get it right on the first try. So remember that. Remember that failure is just another way to learn. It's another way to view learning. I have a couple of examples of this. The first one being that I mentioned that I went away to college and then came back. And if my goal was to graduate away from home, I definitely failed in that. But I never look back on that experience as being a failure because I see how much I learned about myself. I didn't want to be a clone of somebody else and play the exact same way somebody else did. I wanted to educate and learn in different ways, and I wanted to value the experience and the education I'd already had before. So I ended up coming home, was exposed to a local university there, completed my degree, and loved it, and got a ton of very valuable training. So remember, sometimes it's more about the learning rather than the goals. Now, that was an expensive learning, I'll admit, but it was way better. The outcome was way better than the initial goal that I had. And remember that those experiments, that iteration, that adapting and changing on the fly is what's going to lead to the innovation. Now, you might be thinking, okay, that's great and all, but how do I fight imposter syndrome or failure? Imposter syndrome, if you're not familiar, is a feeling of inadequacy, self-doubt, perfectionism, fear of failure, or fraud, etc. And I will say that programming is a bit of a double-edged sword. It can make you feel totally insignificant and totally invincible, almost in the same split second, right? Remember that a typo can break the most beautiful code. But here are some ways that I go about combating imposter syndrome or failure. And all of us are going to struggle with this more some days than others and so on. But I start small. I start with a very small learning. Any learning, no matter how small, is something. It's progress. Pick something you like. There's no reason you have to start with a keynote. Scale that down a little bit. Start with something that's a little bit less risk, less fear of failure, and build those up, compound those over time. And then remember to document or share what you've learned. And that could be done a variety of different ways. You could just tell a colleague about it. You could blog about it. You could just jot some notes or a journal entry down, or send a commit to a repository somewhere, whatever makes you most comfortable. Document that achievement. And then remember to every so often look back on the progress you've made and realize how far you've come. That's the one that most of us, including myself, tend to forget. All right, I'm a naturally risk-averse person. You might not think so. I do take a while to make big decisions. I definitely didn't have a goal to become a developer advocate, podcaster, blogger, etc. But I compounded those small learnings over time. I knew nothing about Neo4j or graphs when I joined 7 years ago, but I just took it one day at a time. Here's what I'm going to learn next. Okay, what about if I try to integrate with this thing? Or how does this work if I try to look at it this way? And those compounded over time. And then all of a sudden I got to a place where it's like, I really want to help others not fall into the same holes that I fell into or miss the same things I did. So I'm going to write blog posts. So hopefully I can help others avoid the same mistakes that I made going through that learning. And that's when it just kind of took off. I started blogging, and then all of a sudden, a few years later, I started podcasting. And last fall, I helped co-write an ebook and all sorts of interesting things. It's just funny where those small learnings take you over time. Now, when I think about the last 7 years at Neo4j, I realize how far I've come. And I'm really proud of that. But I'm really excited to also see where I'll be in 2, 5, and 10 years and beyond. How can we make technology interesting and helpful and open to anybody else who might want to show up? First of all, don't do what everybody did to Firefly and shut it down after a season, right? Give everything a chance. And for those of you who don't know, Firefly is another science fiction TV series. They shut down, they canceled the series after 1 season, and then they actually came back. There was enough uproar that they came back and they did a movie to kind of tie up loose ends and dot their I's, cross their T's, and so on. But they definitely killed it before its prime. Don't do that to other people coming into technology, right? We need those outsider whys to challenge the status quo. So first of all, remember that the only constant is change. That's Java syntax, for those of you who don't know. So the only constant is change. We're constantly going to be moving forward, changing, adapting as things go. Remember that skills are more important than qualifications, and that we are all in this iterate and learn process. We're going to make mistakes. That's okay. But it's how you pick yourself back up and you keep learning and you move from that point. I'm going to leave you with one final quote from Grace Hopper, and that is the most dangerous phrase in the language is, "We've always done it this way." It's easy to get stuck on our own perspectives, caught up with our own responsibilities, our own jaded views, but I encourage you to challenge convention and innovate. Thank you so much and enjoy Devnexus 2025.